Now, first of all, today we're going to look at the layout for the folder. Now, I've already given this to you. So, basically, front page of your folder should have photograph or 3D drawing of your project. The name of the project, that's Construction Studies Project 2017, and your exam number. Okay. Then, contents page a second, and this is basically what you have on the contents page. But what I've done here is basically shown how many pages. Okay, so it's not the introduction is 1 page. Next thing then, plan of the project 3 pages, and so on. Now, at this stage of the year, what we're going to be looking at is we're almost finished the making of the project, or basically finished it. What we have to look at is critical appraisal, which is 2 pages long, and then we have to look at conclusion. Okay, so what we put in conclusion, and then we'll have a look at the 3 experiments. Now, the 3 experiments you're looking at is 9 pages. Now, we'll look at why they're important as well. Now, basically, the introduction that you've done at the start of the year basically was a paragraph explaining what you're going to do. It's kind of like a design brief, and then 3 aims. Now, them 3 aims were very important, and then make finishing the project a lot easier. Okay, now next thing then, planning the project, we've covered that already. Research, gone through it, and basically what we have here, the research for models, research for furniture. Next thing then, what we have is drawings. Give your 3 design ideas, your final solution, working drawings then between 4 to 6 pages, cutting list 1 page. Then the making of the project, and basically making the project is if you've been taking pictures as you've been going along, all you're doing then is putting in all them pictures and writing a brief description of what's happening. Okay, and it's the step by step, and the examiner should see in your folder basically the very start of your project all the way to the end, how you made your project. It's the same as buying any, say, woodwork magazine, and they go through a particular table that they're making. They'll show the wood that's selected first all the way to the finished project. Okay, the same thing in your folder. Now, what we're looking at today is critical appraisal. So this is to evaluate your project under the following headings. Now, list them as good points and bad points. It's the easiest way to do it. So we'll look at that today. Now, the quality of planning, okay, function, finish. Now, it should be about 2 pages. Okay. Next thing then is conclusion. Conclusion, then comment on your practical experience during the making of your project. And we'll look at how you write that up, and that's to be 1 page. Now, this is all other extra notes that I've given you on this. Now, you've got all this already. Okay. Now, what we'll look at then is, first of all, if we look at just why the conclusion is important and the critical appraisal is important. Now, if we look at this here is the marking scheme. So the marking scheme for critical appraisal for a project for quality, function, and finish. Now, if you're doing a model, there has to be a function to the model. So a function of a model is to show a 3D representation of that part of a building that you've produced. Okay, that's the function of it, whether it meets that or not. Okay, does it look like a part of a building? Okay, now obviously the function of a piece of furniture, if it was a chair, that you're first of all able to sit on it. Okay, and so on. Okay. Now, quality, how well the thing is made. So obviously this is where people that make furniture have to write about how well they've made the piece of furniture. Okay, that's where you can list bad points and good points very easily. For the people doing, we'll say, models, it's a bit harder to do quality, because basically you're making a model. It's very easy to make a very good model. Okay, so the quality of the model should be good. Now, the finish then, again, on a piece of furniture, very easy to write up on the finish. It's either got a very good finish, it's got a bad finish, how could it be improved, or what you did wrong. For people doing, we'll say, project or model project, basically what you're looking at is you might say, I might have used different paint, should have used stone effect paint on it rather than just grey paint, okay, to make it look more realistic. That's basically what you'd say there. Now we'll have a look at a sample of how that's done. Next thing then is conclusion from practical experience of project work. Now that's your conclusion. What they want to see in your conclusion is basically two things, and I tell students always there's only two things you write in a conclusion. First of all, they want to know in the conclusion what you learned, because why would you do a project if you're not going to learn anything from doing a project? So you write the first paragraph of what you learned by doing a project. Okay, now you'll mention about time management, how you should have maybe used your time a bit better, planned it out a bit better. Whereas a lot of people, what they'll realize is at the start they don't work hard enough, and then towards the end, getting close to deadline, they have to work do a lot more work because they haven't planned it out properly. So they'll learn that. So for the next thing, that next project you do, they'll actually probably time it a lot better. Other things that you learned is maybe you learned that, okay, you're not as good at making furniture as you thought you were. Okay, or you learned that you're actually well able to make furniture and you've actually gained confidence. Now that's in the first paragraph. Second and third paragraph, possibly fourth paragraph, is looking at the start of your project. You set off at the start of the project with 3 aims. Basically, you look at them aims, write about them aims. Did you succeed in them 3 aims? If you did, how you did. If you didn't, why you didn't. And that's what goes into the conclusion. Now, that conclusion is worth 10 marks. Now, if the whole project is only worth 150 marks, that one page is worth 10 marks. And it's the same for the critical appraisal. That's worth another 10 marks. So you can build do as much work on a piece of furniture as on a model, but them 2 pages are worth 20 marks of the 150. And they have to be in the folder. Now, what we'll look at then is, we'll come back to this sheet in a few minutes because we'll look at the experiments. Basically what I want to have a look at now is basically what a good critical appraisal should look like. Now, this is a good critical appraisal. Now, basically what we have here, good points here. This is for the quality of it. This is for the quality of it. So you have good points here. So these are 4 points put down along here. This here is 2 points. Okay. Now, next thing then is function of the project. So what you have here is you have 4 points done here. So these are the good points for the function of the project. Next thing then is you have the bad points. So for the function, you have the bad points here. Okay. Now, like for example here, drawers are slightly too small to have enough storage space. So obviously in this project we had 2 drawers, but they were quite small, so there wasn't a lot of storage. So they've commented on that. Now the next thing that we have here is a bit too short to fit the length of the couch. So obviously they've looked at the size of the table they made. It wasn't big enough for the size of the couch they had. Okay. Now, next thing then is finish. Think about here about how good the finish was on the project, and then the next thing is a bad point then about it. Okay. Now, that's your critical appraisal. So it's over 2 pages, and the easiest way to write a critical appraisal is put it in bullet points. So every piece of information you're putting down is a factual piece of information. Okay. And it's a lot easier way to get top marks. Now, if we look then at the conclusion. Now, the conclusion then is basically what you learned and also your 3 aims. And that's the finish of your project then. Now, and if you look at the contents page, the only thing that comes after the conclusion then is your experiments. You put in 3 experiments at the end of the project. Now we'll look at the experiments next. Now, basically looking at this first experiment here. Now, looking at an experiment, you have to have title for the experiment, then date which the experiment was carried out. So you'll notice here, this was the 7th of the 4th, which just happens to be a couple of days time. Today is the 4th of the 4th. So what it is, the aim of the experiment here was to test the absorption of mahogany and ash, to see how much water or moisture they take in. The next thing then is the equipment, so what equipment is needed. Next thing then is the method, how it was done, and then results. So all the results here put in a table here. Then what it is, calculation here of how it was done, and then conclusion. Now conclusion, why do we need a conclusion? Again, to show what we learnt or what the experiment showed you. There's no point having results for an experiment unless you learn something. So what we've learned here is which wood took in more moisture. Okay. Now the next thing here is a photograph. It's important that you include a photograph. And the reason you have a photograph is to show that you did the experiment. The examiner will see this photograph. He will know you did this experiment. Okay. Now, next one here then is to do with a photograph showing the piece of wood being weighed. Okay. Now, next thing here, just a diagram. Now, why do we need a diagram if we have photographs? The reason we need a diagram is a diagram has labels. That's the difference between a diagram and a photograph. A diagram will have labels here, so you label the diagram. That's why you put in a diagram. Now, next thing then is, this here is another furniture one. So what it is, check the quality of different finishes. Okay, fairly straightforward experiment here. And basically what we have here, table here, looking at results here, type of finish, then aesthetics, ease of application, and cost. Okay, and then what you do, conclusion then. And look, experiment here showing the pieces of wood with the finishes on them. Okay, and basically what you're looking at is different types of finishes here. Okay, now next one then, another one to do with furniture. This is testing, we'll say pieces of wood glued together, and then 24 hours later test them. And what we have here is two pieces of wood glued together in the middle, and then weights from a science room, and gradually increase the weight and see where does it break. Okay, when does it break? Okay, so what you have here is, this is the number of newtons held. So this is the type of glues. Okay, now really easy experiment to do. Okay, and that's the finish of the experiments. Now what we'll look at is, we'll look at the experiments here. First of all, what we want to look at is experiments here. Evidence of ability to plan, carry out 3 experiments. Now, experiments should relate to your project work or selected from suitable or suggested experiments outlined in the syllabus for construction studies. Now, basically what I'm telling you is, whatever experiment you do, it has to relate to your experiment, to your project. So, for example, if you're doing a furniture project, you're not going to do an experiment based on concrete, because it has nothing to do with your project. Now, it is in the construction syllabus, but it's far better to do experiments related to your project. Okay. Now, next thing here that we look at, so is, that's the marking scheme. Next thing here is looking at these experiments here. Now, what we have here, the first piece here, this here is just the chief examiner's report. Now, this comes out every year based on looking at candidates that have done construction studies and what they have to have in the experiments and what has been corrected. Now, the main thing that is said by the chief examiner is that students must undertake 3 experiments. Okay, it's only 3 experiments, but a lot of students either do not do the experiments or just do 1 or 2 experiments. You do 3 experiments because it's 10 marks per experiment. Okay, now the next thing as well is you have to show results for the experiment and a conclusion. And then the other thing is, to get full marks, you have to show evidence of you doing the experiment. So that is the results, that is the photograph, that is the diagram. So they need to be done. Now the next thing here is, these are all different types of experiments that you could do. Now what we have here is tests on jointing methods for a project. So if you're doing a piece of furniture, you could test the strength of, say, a mortise and tenon joint versus a biscuit joint versus a dowel joint. Okay, and what you'd be doing there is testing the strength of it. Okay, now the next one then is dovetail, finger, mitre. Next one here, nailed, screwed and glued joints. Which is stronger? Okay, now tests on the moisture content of timber. Now what we have here is the moisture content of a piece of timber, so we'll have a look at that. Then the absorption of wood, so what it is, if you put a piece of wood into a damp situation, how much water is it going to soak in or soak up. Okay, now next thing then is the test on the quality of finishes. Now after that then is test on the strength of structures. Now this is to do with people making models. So what we have here is we have triangulation test for roof members. So if you're doing, we'll say, rafters in your project, this would be a good test to do. Okay, and you have to do it to the scale size. Okay, now next thing then is, this here is a kind of a template for your project. So for your experiment. Title, then introduction. Now introduction, the aim of the experiment. Next thing then, the equipment. Next thing, procedure. Then results, conclusion, and then photograph diagram. Okay. Now, next thing here, you have to put a date on your experiment. Okay, all experiments have to be dated. That's what an experiment is. Okay, it's the same as junior cert science. And then looking at the marking scheme here, there's 1 to 3, 10 marks each. So it's worth 30 of the 150. So it's worth 5% of your final grade. Okay, now what we'll look at so then is different types of experiments. Now what we have here is we have a whole heap of different experiments here that a student could do. Now basically I'm going to zoom in on a few of these and just go through them. So the first one here is to determine the moisture content of a piece of wood. So what you're doing here is you're getting a couple sample pieces of wood and then you're putting them into different situations. So basically what you're doing here is you put it into an oven, low heat, 100 degrees Celsius for a set period of time and then weighing them. So your initial weight is here, then your final weight is here. So this is the dry weight. Then you work out moisture content. Okay. Now next thing here, conclusion, what you learn from that. Now next thing then here is note to students desired moisture content. So this is the desired moisture content for a particular timber. Okay. Now this here, capillary test for narrow spaces. Now this here, what we have here, we've got a capillary groove in certain places of a building. For example, the chimney cap, the windowsill, they've all got capillary grooves to stop moisture coming in. The capillary test here, you take 2 pieces of glass or Perspex, clear Perspex. You put it into a basin of water, you put an elastic band around it, and what you do is you put a matchstick in between the 2 panes. Now, one of the edges touch, one of the edges there's a space. Now what you'll see from doing the experiment is you'll see the water rise up along where the 2 edges meet. So that means that water will flow between narrow spaces. Okay, so it's the very same as if you have a cup of tea, you leave a spoon in the cup of tea, and you look at the spoon and where it's touching the edge of the mug and see the tea filling up the gap between where the spoon and the cup touch, that's capillary action. Okay, the same thing would happen in buildings. Okay, the same in wall ties. So if you've made a model, this is where you could use this, because you have wall ties in the model. So what it is, you've got your capillary action happening in the wall ties if you don't have the bend on the wall tie. Okay, now next thing here, that's just the resultant conclusion. Now what we have here then is several other experiments. Now, and a lot of these are aimed at either furniture or models. So what we're looking at here is the aim of this experiment, putting a table together different types of glues. So this is testing the different types of glues that we've looked at. This here is the structural. So if you have a roof, this could be done. So what you'll see here, it's kind of self-explanatory. You make one rafter, basically your two rafters and your ceiling joist. Then the next one, you add in two struts. The next one, you have your two struts and your two ties. And then you just hang weights off the bottom of them. Okay? And you have to determine which is the strongest one. So obviously the increased amount of timber, the more structural the better structure it is. So obviously the third one there should hold the most weight. Okay? Now, next thing here is this here, for anyone doing models, what we have here, weights again from the science room, and this here is kind of a cantilever experiment. Now, this experiment we've done here in the past, you get small pieces of timber, you put it between two benches, and then you hang weights off of it. Now, what you'll do is you're going to test how much that piece of timber deflects by. Now, where would you have that in your project? Now, where you have it in your project is, say if you have a suspended floor done, you have floor joists. Obviously floor joists have to be a certain size. This experiment would prove that if you have floor joists of only 100 mil and you put weights on them, they'll start sagging down. Whereas if you have a floor joist of 225, it won't sag down at all. Okay, now this here just shows deflection of a cantilever here. Done. Okay, now next one here is for anyone that has done anything with insulation. So if you've done something, say with passive or we'll say timber frame, this is a good experiment and an easy enough experiment to do. What we have here, piece of airboard insulation, we have a piece of kingspan insulation. Basically what we're doing here is, this is the experiment set up. We have electric heater blowing out warm air. We have a thumbtack stuck onto the end of the insulation, okay, on the opposite side with a bit of candle wax. You turn on the heater, you record the time until the thumbtack falls off. Okay, and you repeat this experiment 3 times. So you do 3 times with the airboard, 3 times with the kingspan insulation. Now, really simple experiment to do, okay, but it'll show which insulation is better. And what the experiment is showing is that the heat coming from this, it will go through insulation eventually, but how long it takes for it to go through. Okay, and this is an experiment that we'll be setting up and doing this year. Okay, and that's pretty much all the experiments, and just write them up. Okay, so all of this is in your OneNote to give you a guide. So on Thursday morning we'll be starting off with doing these experiments, and then over Easter you write up the experiments. Okay, make sure you have photographs taken.